Hi, Gabriel. Good to see you again. Gabriel, just give me 2 minutes, okay? Then we will start the class, all right? Okay. Good, Gabriel. Good to see you again. At least your name, and you are there, I hope. So it's our third class about straight lines and triangles. Today we will talk about another important concept, that is angle sum of polygons. That means that if you are given any polygon and how you find the sum of the interior angles. Also, we will talk about the sum of the exterior angles, and we will solve some problems involving these concepts. Okay, so we know that actually when we talk about polygon, right, the first that comes to our mind is triangle. That is very fundamental polygon. It has three sides and it is closed figure and it is two-dimensional. Two-dimensional means that if you just put this on the surface, the flat surface, maybe on a table, for example, it completely touches the table, the surface of the table. It's not curved, it is just flat. So a polygon is a two-dimensional geometric figure that has a finite number of sides. If it has infinite number of sides, then it becomes a circle, and it's not called a polygon because it is a curved figure. The sides of a polygon are made of straight line segments connected to each other end to end, right? And those actually, intersection points or union of these ends of the sides of the polygon, we call them vertices or vertex. So the line segments of a polygon are called sides or edges. The point where two line segments meet is called a vertex or corner. You just highlight this. It is sides or edges. It is vertex or corners. Henceforth, an angle is formed. An example of a polygon is a triangle with three sides. Let's say here we have triangle, square, pentagon, hexagon, and these are some examples for polygons. Of course, here they are regular polygons, but of course it doesn't have to be regular polygon. And we can draw a lot of different polygons. A circle is also a plane figure, but it's not considered as a polygon because it doesn't have any side, right? Or we do not construct a circle using line segments. That's why it is not a polygon. So therefore, we can say that all the polygons are 2D shapes, but not all the two-dimensional figures are polygons. We have a lot of 2D shapes, right? They are not polygons. For example, if you just draw a circle or oval or any kind of curved figure, it is not polygon. For example, also here, we have a curve maybe, and one side is straight line. It's not a polygon, right? And maybe we have three this kind of side, but this part is, it is something like this curve. Also, it is not a polygon. Okay, polygon means that all sides of the polygon must be straight lines. All right, now another concept, concave and convex polygons. If all of the interior angles of a polygon is smaller than, less than 180 degrees, the polygon is called a convex polygon. So that means that every interior angle of a polygon, if it is less than 180 degrees, then we call this convex polygon. And otherwise, it is called a concave polygon. Now, you see here in this picture, the first one is convex. Why? All of these interior angles, this angle, for example, this angle, or this angle, and this angle, all of these interior angles, they are less than 180 degrees. And that's why it is called concave. How about in the second one? Yeah, this one is less than 180, and this is less than 180, less than 180, but one interior angle, right? This one, it is greater than 180. Here, this alpha, let's say alpha is greater than 180 degrees. And that's why it is called concave polygon. All right. Some formulas say about regarding the interior angles of a polygon. A line segment, which is not a side of a polygon, connecting two vertices is called a diagonal of the polygon. Okay, adjacent side means that actually, when do we call an adjacent side? If they are sharing a common vertex, then we call them adjacent sides. For example, if you look at this square, let me just label them. This one is A, and this is B, and this is C, and D. Side AB and BC, they are adjacent because they are sharing a common side. And side BC and CD also, they are adjacent. And D and C also, they are adjacent. And DC and AD also, they are adjacent sides. And how about adjacent vertices? They are just the end of one side. Like, for example, vertex A, vertex D, they are adjacent. Vertex A, vertex B, also they are adjacent because they are next to each other, or they're just the ends of one line segment or one side. Okay, so here we are saying that how we are defining the diagonal. Diagonal is a line segment that connects two non-adjacent vertices of a polygon. As you see here, B and D, they are non-adjacent vertices. A and C, non-adjacent, right? So we have two diagonals. I mean, the square has two diagonals. How about this pentagon? And also pentagon, let me label it as vertices by, let's say this A, and this one is B, and this one is C, this one is D, and this one is D. Let's say AC, non-adjacent, CE, non-adjacent, AD, non-adjacent. So if you connect non-adjacent, by connecting, let's say, non-adjacent vertices, we can obtain the diagonals of any polygon. But here particularly, we are talking about pentagon, pentagon. Anyway, so n-3 diagonals can be drawn from any vertex of an n-sided convex polygon. Why? Because see here, A, right, and it has 5 sides. If we join A with E, it's not a diagonal because they are adjacent. And A to B also, they are not, it will not be a diagonal because they are adjacent. But so 3 points, right? So how many points left? n-3. So using A, I can draw n-3 polygon diagonals. So an n-sided convex polygon has n times n-3, n times n-3 over 2 diagonals. So this one is n-2, and n times n-3 over 2. And also they separate the polygon into n-2 triangles. An n-sided convex polygon has n times n minus 3 over 2 diagonals. Also, this is a theorem. Maybe you can prove this in the future. I don't know. If there's a question, also you'll prove this. And that is a kind of theorem. If you're given any polygon, an n-sided polygon, it has n times n minus 3, what is it? Diagonals, convex polygon. So we have to pay attention here, convex polygon. The sum of interior angles of an n-sided polygon is 180 times n minus 2. We will prove this in the exercises. Why is it so? The sum of exterior angles of an n-sided polygon is 360 degrees, is fixed. If you are given any polygon, maybe triangle or quadrilateral or pentagon or hexagon or heptagon, octagon, decagon, or whatever it is, n-sided polygon, the sum of the exterior angles is always 360 degrees. The reason is because I can draw inside a circle any sided polygon, right? And since a circle is a right angle, it's always 360 degrees. But of course, we will prove them in a bit different way. Just this is the idea. Okay, in this question, find the sum of interior angles of a pentagon. Okay, in this question, how do you find this? So since it says that, right, in the question, the sum of the interior angles of any side of polygon is 180 times n minus 10. So here it has n sides, right? Let's say that is A, and this one is B, and this one is C, and this one is D, and this one is C. So let's say the sum is S, that's equal to 180 degrees times 5 minus 2, which is equal to 3 times 180 degrees. That's equal to 540 degrees. So the sum of the interior angles of any pentagon is, what is it? 540. And also, if you wonder why is it so, immediately we can just draw diagonal. For example, if I just draw this diagonal from here to here and from here to here, for example. Okay, see here now it is divided into 3 parts, right? So now the sum of the interior angles of the first triangle, let's say this one is the first one, is equal to 180. And how about the sum of the second triangle, also 180? The third one, 180. So we are just adding these angles, right? Angle, this one, plus this, and plus this, plus this, plus this, and plus this, plus this, plus this angle, plus this angle, which is all the interior angles of this polygon. And that's why it's equal to 180 degrees. I mean, we have 3 triangles, and the sum of these, I mean, there's 3 triangles, right? 3 times 180 degrees, that is 540, which gives us the sum of the interior angles of this pentagon. Okay. Next question, find the sum of A, B, C, D, E, and F in the given figure. Okay. Here, at once, when you look at this, it doesn't look like any polygon, right? So what can we do here? Should we just add some kind of lines and do it, or we can find another way? But here, first, if you look at this angle 1, for example, angle 2, right? So, okay, we have to find A, B, C, D, E. What is angle 2? Let me just label some angles. Let's say, okay. Here we have 1. Okay. 1, 2, 3, 4. All right. Let me just label also, for example, from here, let's say this A. Let me use red. Okay. Vertex A, vertex B, and straight line D, and straight line this one. Let me just call this. We don't have H. Okay, let's just H and A. So how many sides? A, B, 1, B, D, 2, D, H, 3, and the HA 4. So the sum of, right, this ABDH is equal to 360 degrees, because solution, if you look at the quadrilateral A, B, D, H, the sum of the interior angles is equal to 360 degrees, right? Now from here, so what is this angle? Let's say, for example, here we have angle A, all right, and this one is angle B, okay, and this one is angle D. And how can I find this angle? This angle is the exterior angle, right? It's angle, no, not this angle. Okay, I need to find H. What is H? If you look at the triangle C and the E, right? C, okay. First, angle F plus angle C, right? And this one is the exterior angle. So this angle is equal to, let me write here, angle F plus angle C. Okay. Now from here, if you add this angle E, right, this angle, this one is exterior angle for them. So now from here, let me just write here, angle H is equal to angle F plus angle C plus angle E. Okay. So now since this one is 360 degrees, that is angle A plus angle B plus angle D plus angle H. And what is angle H? That is angle F plus angle C plus angle E. That is equal to 360 degrees. Actually, all of this A, B, D, C, A, B, C, D, E, F, they are just all of these angles, right? A, B, C, D, E, F. So the sum of these angles is equal to 360 degrees. We have just used the property from the last part, from the last lesson, right? The sum of the two interior angles is equal to the exterior angle of the third angle. All right, another example, find the sum of angle A, angle B, angle C, angle D, and angle E. Angle E and angle F. Okay. So here, if I just connect this A and D with this dashed line, okay? So at the time, what do we get here? This A, B, C, D, it is a quadrilateral, right? It's a quadrilateral. So we have to find the sum of these angles. All right, from here, okay. Angle E, angle F. All right. Now we can show that actually for any 4 points, right? A, B, C, and D. AC, AC, AC intersect BD. Okay. A plus B plus C. Okay. Angle E, angle F. Okay. Let me just a very simple thing. Okay. Here, angle E, angle F. How about this angle? This angle is equal to, let me just write here. Okay. That angle is equal to 180 minus angle E minus angle F. So these are vertical opposite angles. Also, they are equal, right? So if it is so, let me just write here. I don't know this angle. Let's say this alpha, and this angle is beta, right? So from here, alpha plus beta plus this angle, the third angle, what is it? Is equal to 180 minus angle E minus angle F. This is equal to 180 degrees. So 180 cancel each other. From here, then alpha plus beta is equal to take E and F to the right-hand side. That's equal to angle E plus angle F. So we have just proved that the sum of these angles, alpha and beta, is equal to the sum of angle E and angle F. So now if you just add these angles, angle A plus, what is it, angle B plus angle C plus angle D plus angle E plus angle F, right? See here, if I just join now AD, actually this ABCD, it gives us, what is this? A quadrilateral. It is a quadrilateral. And the sum of the interior angles of a quadrilateral is 180 times 4 minus 2. That's equal to 360. You see here, this is angle A plus alpha, and angle D plus beta plus B plus C. That's just equal to 360 degrees. And that's why here, instead of this alpha plus beta, I can write E plus F, right? So A plus E, it forms that angle, that big angle, and also B plus F, right? They form this big angle, and the CD. They just form a quadrilateral. That's why the sum of these angles is equal to 360 degrees. You can also just write like this. Here, this one is angle B, and this one is angle C, and this one is angle A, and this one is angle D. So now if you just combine or connect point A with point D, draw a line segment, then ABCD becomes a quadrilateral. If you look at the interior, the sum of the interior angles of this quadrilateral, A plus alpha plus D plus beta plus B plus C. That's just equal to 180 because alpha plus beta equals angle E plus angle F. Gabriel, is everything clear? Good. All right, example 4. In the question, AF is parallel to CD. So here AF is parallel to CD. And angle AFE is equal to ABC. So this AFE, this angle, let's say this alpha, is equal to ABC. And also this angle is alpha. They are equal. And FE is perpendicular to DE. So FE is perpendicular to DE means this angle is 90 degrees, right? And angle D equals 125. So this angle is 125 degrees. Angle C is 110. Angle C is 110 degrees. Find the value of A. Okay. So now, since actually this AF is parallel to CD, okay, now if I just extend E to G and also F to G, they meet each other at this point. Okay. So now at the time, what do we get here? This one is 90 degrees. Okay, this one is alpha, 180 minus alpha. Okay, just a minute. Okay, so AF is parallel to CD. Now from here, let me just change the color. So what is this angle? Angle G. So angle G, solution, angle G is equal to 180 minus 125, which is equal to 55 degrees. Why? Because here DG, right? It is just transversing this AF and CD. AF and CD are parallel lines. If you remember, if you draw parallel lines here, these lines are parallel. If you draw a line here and this angle, the sum of the interior angle is equal to 180. So if this angle is 125, this angle should be 55. right? So that's why angle G is equal to 55 degrees. 55 degrees. Now from here, A, B, C, D, and G, right? What is it? It is how many sides? 1, 2, 3, 4, 5. It's pentagon, right? So now the second one is, if you look at this polygon A, B, C, D, G. Okay, it is a pentagon. And the sum of the interior angles of this pentagon is 180 times 5 minus 3. And we have just calculated this as equal to 540. So at the same time, what is the sum of these angles? It is angle A. I don't know. What is angle A? Angle B, it is alpha. Angle C, 110. Angle D, 125. And angle G, it is 55, right? So that is equal to, 300 and the, no, pentagon, 1, 2, 3, 4, 5. So that's equal to 540. Now from here, we can get here angle A plus angle alpha is equal to 540 minus 125 and 55. That is 180, and the 180 minus 110. And 540 minus 180 is 360. 360 minus 110, that's equal to 250 degrees. Okay. On the other hand, how can I find alpha? If you look at the triangle, we can find a triangle in triangle, what is it? EFG. EFG, right? And the sum of the interior angles, angle E, that's equal to 90 degrees. And angle G, it is 55 degrees. What is angle F? This angle F is 180. No, actually just exterior angle. Okay, then I don't have to do like this, because alpha is an exterior angle of angle E and angle G. So alpha is equal to 90 plus 55. That's equal to 145 degrees. Yeah, that's it. So now if I substitute this into this equation, then angle A plus alpha, that is 145 degrees. On the right hand side, we have 250. So now from here, we can write what is A, angle A is equal to 250 minus 145, that's equal to 105 degrees. Gabriel, is everything okay? Good. All right, let's continue. Another example, it says that ABCD is a convex equilateral pentagon. Equilateral pentagon, that means that all sides are equal, and also all, what is it? Interior angles are equal. P is an arbitrary point in A, B, C, D, E. Prove that the sum of the distances from P to AB, BC, CD, and DE, and EA is constant. So it says prove that the sum of the distances, right, from P to AB, BC, CD, and DE, and CDE and EA is a constant. So it says arbitrary constant point. Which point is it? It can be any point. So suppose that, let me just choose that point here. Okay. So now from this point, what is the distances to other sides? Let me just draw here. Okay, it's a bit easier to draw. So this is an arbitrary point P. Okay, this one is P, point P. Okay, so now if you draw a height, right, it says the sum of the distances from P to AB and the BC and CD and DE and HA is constant. Let me just draw those distances. So from P to D, for example, we are talking about this distance, right? And from P to EA, for example, we are talking about this distance. And from P to AB, we're talking about this distance. And from P to DC, it is this distance. And from P to BC, it is this distance. Okay, so these are the distances, right? So distance means it's an altitude. It's 90 degrees. Also, this one is 90 degrees. And this one is also 90 degrees and 90 degrees. And it's also 90 degrees. Okay, let me just label them. Okay, this one is, let's say it is H1, and this one is H2, and this one is H3, and this one is H4 and H5. Here we have the, what is asking here, the question here is we have to prove that this H1 plus H2 plus H3 plus H4 plus H5 is a constant number that's equal to some kind of constant number. Okay. So now to prove this one, now again, actually, I will just, what is it? Combine, connect this P with the vertices of this pentagon. Now this time, let me just change the color. And now if I combine E with P, okay, P with D. Okay, and P with A, and P with B, and P with GC. Okay, so now if you look at this, right, the figures, the area of the polygon is divided into, what is it, 5 triangles. What are those triangles? EPD, EPA, APB, and PBC, and PDC. Now from here, I can just write this equation. Then the area of polygon A, B, C, D, E. Okay, so let's equal to just S. That S is equal to, that's equal to how many triangles? We have 1/2 times H1 times, let me just label this as by, this one is A, this one is B, and this side is C, and this side is D. Oh, actually it is convex equilateral, right? All sides are equal actually. Let me just write here this side A, 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 A. So 1/2 times H1 times A. The second part is 1/2 times H2 times A. Third one is 1/2 times H3 times A. And the plus 1/2 times H4 times A, and 1/2 times H5 times A. So on the left hand side, this area, right, is pentagon. Since this does not change, let's say that area is equal to S. On the right hand side, 1/2, that is A/2 is a common factor. Inside the parentheses, here we have H1 plus H2 plus H3 plus H4 plus H5. Now from here, if I multiply both sides by 2/A, at the time, what do we get here? So this H1 plus H2 plus H3 plus H4 plus H5 is equal to 2 times S, S the area of the pentagon, over A. S area does not change because A does not change. It's a constant, right? We are given any particular pentagon. So on the right-hand side, area over one side of the polygon, that is A, it's a constant number. It does not change. So now we have proved that the sum of the distances from any point, any arbitrary point inside the pentagon to all sides of the pentagon, always a constant number, is constant. It does not depend on, what is it? The location of this point inside the pentagon. The sum is always constant. Let's say for examples part, now we also solve some questions from exercise 3. Question 1. For a quadrilateral ABCD, AB equals 3. So just write them. AB is equal to 3. BC is equal to 8. CD is equal to 2. And find the range of the possible values of DA. Okay. And also for any polygon, actually, the sum of, for example, n minus 1 sides always must be greater than the length of the last one side. It's always true. So here, okay, this AD, okay, the third side, let's say its length is D. Now, otherwise we cannot consider from here. I know that this D, it should be less than the sum of the remaining side. That is 2 plus 8 plus 3. So dot, dot, dot. From here, what is D? D is less than 13. It cannot be equal to even 13 or greater than 13. Otherwise, okay, if it's 13, okay, we cannot construct a quadrilateral. It should be less than 13. Why is it so? Because when you're constructing this is one side, and this one is another side, and let's say the third side, right? And when you construct the fourth side, it must be less than the sum of this one. Otherwise, you know, if it is greater than, it will be too long. We cannot form a quadrilateral, convex quadrilateral. Anyway, okay, now we actually found possible value of D, right? Maximum it is, it should be less than 30. Okay. Now the second part is here. How about if I just, actually this is the first one, the second one, if I just pick other 3, for example, let's say 2 plus D plus 3. So 2 plus D plus 3, and also it must be greater than the last side, that is 8. Now, if you solve this, we get from here D must be greater than 8 minus 5. It should be greater than 3. Okay. And how about if you pick other side, for example, let's say D2, 3, right? If I take D8, for example, D plus 8 plus 3 is greater than 2. It's always greater than 2 because here we have 8. So others actually doesn't give it change anything. Now from here, now I can write the conclusion now. So the range of the values of D, the fourth side AD, so let's say this AD, it must be less than 13, and it must be greater than 3. So the range is 13 minus 3 is just 10. So it cannot be less than 3. It cannot be greater than 30. Question 2. Prove that the sum of interior angles of an n-sided polygon is 180 minus 180 times n minus 2. Okay, how do you prove that? Since actually we know that if you're given n-sided polygon, right, we can draw n minus 3, what is it, diagonals. So n minus 3 diagonals means that we can form n minus 2, what is it, triangles. Okay, suppose that we are given n-sided polygon. That n-sided polygon is maybe something like this. Okay, I can continue actually. Okay, and continue. So let me just label the vertex as A1, and this one is A2, and this one is A3, and this one is A4, dot continuous, and this one is AM. So that is n-sided polygon. Okay, it doesn't have to be regular. All angles are different. Now, if I draw, for example, here, starting from A, right? Let me just from A. And now how many diagonals I can draw from A1 to A3, right? So now I form one triangle that is A1, A2, A3. It is one triangle. And after that, if I just join this, right? Now I form another triangle that is A1, A3, A4, right? And continue, if I just join this one, for example, let's say, okay, it's something like this, we can form A1, A, n minus 1, and here we have AF. Now, how many triangles do we have here? Let's see, here we have actually the sum of each triangle, 180 degrees, 180 degrees, and dot, 180 degrees. So now how many triangles do we have here? If you look at this, the second one, for example, it is 2 and 3 until n minus 1, right? Or the third one is from starting from 3 and 4 until n. How many triangles do we have here? Here we have n minus 2 triangles. And the sum of the interior angles of each triangle is equal to 180 degrees. So the sum of the interior angles of any n-sided polygon is equal to 180. And inside the polygon, actually, we have n minus 2 triangles. And the second one is prove that the sum of exterior angles of any convex polygon is 360 degrees. Okay. In a similar one, okay. Suppose that, okay, suppose this, it has, say we are talking about any convex polygon, okay, suppose it is n-sided polygon. And that means it has n interior angles. Those interior angles are, let's say this alpha 1, alpha 2, alpha 3, dot, alpha n, right? Now, and these are interior angles. And also suppose that this beta 1, beta 2, beta 3, dot, beta n, these are corresponding exterior angles. Okay, like for example, let's say, let me just draw some part here. We have some actually part of this polygon. If this one is alpha 1, so this angle should be beta 1. If this angle is alpha 2, and this angle is beta 2, right? So since it is so, now I can write this equation now. Here we have alpha 1 plus beta 1 is equal to 180 degrees. Alpha 2 plus beta 2 equals 180 degrees. And dot, alpha n plus beta n is equal to 180 degrees. Now, from this relationship, I can write, what is it? Beta 1 as 180 minus alpha 1. Beta 2 equals 180 minus alpha 2, dot, and the last angle, beta n, that's equal to 180 minus alpha n. So now if you add this, beta 1, beta 2, beta n, what is it? The sum of the exterior angles, right? So the sum of exterior angles, let's say, exterior angles is equal to beta 1 plus beta 2 plus and beta n. It is n-sided polygon. And now if you just add the right-hand side, right? How many 180 do we have? Here we have n. So here we have 180 times n. And minus, now I have to add alpha amount, alpha 2, alpha 3, alpha n. So minus is a common factor. Here we have alpha 1 plus alpha 2 plus alpha n equals, that's equal to 180 times m. And we have just proved that in our previous question, right? The sum of the interior angles of inside the polygon is 180 times n minus 2. So now if you simplify this, 180 minus n minus 180m, that's equal to 0. Minus 180 times minus 2, that's equal to 360 degrees. So the sum of the exterior angles of any polygon is always 360 degrees. Okay. Another question. Find the sum of A, B, C, D, E, F, and G in the figure below. How do you prove that again? Of course, in this kind of question that I told you, if the picture is greater, bigger, then we can see this much better. Let me just zoom in a little bit or enlarge this figure so that I can put my letters in is. So we have to find A, B, C, D, E, F, G, right? Let me just start from A. Okay, this A and B and A, let's say C, and let's say here this angle is G, let's say this H and F. So now it is a quadrilateral, right? So solution here, angle A plus angle C plus angle H plus angle F, because it is a quadrilateral A, C, H, F, right? And also A. It is 1, 2, 3, 4 quadrilateral. So that's equal to 360 degrees. Okay. So now, of course, we don't know H. Now I'll try to find H. What is H? From here, H is equal to okay. Angle H is equal to angle D plus this angle. And this angle is equal to this angle. They are equal. Okay. All right. Angle E just a minute. Okay, A plus C plus H plus F is equal to 360 degrees. Now we need to find H without using, what is it, ACF. ACF, okay, we have already used this angle, also use this angle, also use this angle, right? So now using BGD. And how about B, D, and also this angle? Let's say this one is HI, right? And also angle B plus angle D plus angle I plus angle G, also that's equal to 360 degrees, right? Angle B plus D plus I plus G, that's also equal to 360 degrees. B, D, I, and G. Okay. So now, when we just say I, we mean this angle, right? We mean this angle. So what is this angle? This angle is 180 minus I. 180 minus I. Okay. So at the time, this angle H will be angle E plus 180 minus I. Right, this is the corresponding angle. So now instead of H, let me just write here. Here we have angle A plus angle C plus angle F plus H. Instead of H, I can write angle E plus 180 minus I. That's equal to 360 degrees. And now I have ACFE, right? What is I? Also for I, as you hear from this equation, angle I is equal to 360 minus angle B minus angle D minus angle G. So if you substitute there because of this minus, right, what we have here? Here we have angle A plus angle C plus angle F plus angle E plus 180. Because this minus minus, it becomes plus. So here we have minus 360 because minus, and others it becomes plus. Plus angle B plus angle D plus angle G. On the right hand side, we have 360 degrees. So let me just label that sum A, C, F, E, B, D, G as S, okay? This will be equal to, on the right-hand side, we have 360 and minus 360, take to the right-hand side, plus 360, and also plus 180 minus 180, which is equal to 540 degrees. So the sum of those angles is equal to 540 degrees. Okay, prove that for any 4 points, A, B, C, D, if AC intersects BD at X, then ADX plus BAX equals BCX plus CBX. So AC intersects BD, right? Here we are talking about, let's say this AC. So this one is A and this one is C. Okay, intersects BD. And this one is, let's say this one is B and this one is D. Okay, intersect at X. So this point is X. So we have to show that ADX, that is ADX. Let me use, okay, ADX and the BCX, right? And the CBX, and the BCX. Okay, that's it. So if you're given, of course, this BC and AD, they are not parallel. They don't have to be parallel. Okay, we have to show that ADX. Let me just use letters. Okay, it's much easier. Let's say this one is alpha. DAX. Let's say this angle is beta. Okay, BCX. This angle is, let's say it is X. Not X, alpha, beta, gamma, theta, and what can I write here? Let's say this Y degrees. And the CBX, this one is, let's say it is Z, okay, degrees. So we have to show that what we are trying to show here is alpha plus beta is equal to Y plus W. So we have to show this. Okay. How do you prove that they are equal? Now from here again, alpha plus beta, right? And this one is this third angle. The exterior angle is this. So the exterior angle of triangle BCX, right, for X is equal to, what is it? Y plus Z. At the same time, actually, alpha plus beta, right, and it is x plus z. Also, it is the exterior angle for alpha and beta. So now from here, then alpha plus beta is equal to y plus z. It's always true because angle BXC, it is the exterior angle for angle X when it looks to this direction side, and also angle X when it belongs to the triangle BCX. Okay. So let me skip this question. You can also try this. Just try to solve a bit. If you have more time, then we will solve that question, okay? The sum of interior angles of a convex polygon is 2008 times of that of the exterior angles. The sum of interior angles of a convex polygon is 2008 times the of the exterior angles. The polygon has how many sides? It has at most this many acute angles. Okay. So the question is a bit tricky question. So suppose that we are talking about n-sided polygon. And what is the sum of the interior angles of this polygon? That's equal to 180 times n minus 2. This is the sum of the interior angles. And it says that here 2008 times, so that is equal to 2008 times of that of the exterior angles. That means that of that, the sum of the exterior angles of that polygon. And what is the sum of the exterior angles of the polygon? It is 360 degrees. So now we have to solve this. First, if you divide both sides by 180, so n minus 2 is equal to 2008 times 360 over 180, which is equal to 360 over 80, 180, that's 2. 2 times 2008, that's equal to 4016. Dot, dot, dot. What is n here? N is 4018, because 4018 minus 2 is this. So this polygon has 4018 sides. Okay. And it has at most how many acute angles? Okay. It has at most acute angles. Acute. It has at most acute angles 4018. Okay. How do we answer this question? It has at most how many acute angles? Four 2018. Okay. So actually it has at most how many acute angles? It doesn't have any acute angle, I think, because it has 4018. And the second part is, this one is the first part. The second part is it has 4018 sides. And let's say the exterior angles, that is alpha 1 and alpha 2 plus, and here we have alpha 4018. The sum of the exterior angles is equal to 360 degrees. And let me just call this exterior angles by S exterior. Okay, so this S exterior is equal to 360 over 4018, which is equal to, and the thing is equal to 360. Okay, 360 is divided by 4018. That's equal to 180 over 2009. So what does it mean? It means that we know that this alpha 1, alpha 2, alpha 4018, they are all positive numbers. And the sum of these positive numbers is less than 180, which means that each angle, this alpha 1, alpha 2, alpha 4018, it must be less than 1, right? Which means that its corresponding interior angle is greater than, or is it 100, 180 minus 1, it is greater than 179. So it doesn't have any acute angle. Okay, another question. Left. Okay, let's solve two questions. And for a quadrilateral ABCD, if B equals 3 times A, and it equals 2 times C, and D is equal to C plus 20, find the values of A, B, C, and D. So in this kind of question, we try to express everything in terms of one angle. And since we are talking about a quadrilateral, so the sum of the angles A and B and C and D is equal to 360 degrees. So now I can express everything in terms of maybe D or C or something. And for example, which one? Let's express everything in terms of A. Okay, so from here angle A plus, what is angle B? Angle B is 3 times A. So that is 3 times angle A plus C. What is C? C is 3 over 2A. So that's equal to 3 over 2 times angle A plus angle D, it is C plus 20, and C is equal to 3 over 2, 3 over 2 angle A plus 20. That's equal to 360. Now here we have 1 plus 3, it is 4, 1.5, 1.5, it is 3, 4 plus 3, that's equal to 7 times angle A. On the right-hand side, we have 340 degrees. Now from here, what is A? Angle A is equal to 340 over 7. which is equal to, it's not divisible by 7, so 4, 3, 7, 8. Okay, let me just check. It is A, B is 3A, C is 3 over 2A. So D is C plus 20, C is 3 over 2A plus 20. That's equal to 360 degrees. Quadrilateral, it is 2, okay. It is 340, and 340 over 7. Okay, that's it, nothing to do. And if it is 340, what is it? It is 48, 48, 4 over 7, 4 over 7 degrees. I don't know. Let me just like this, leave it like this, degrees. Okay. So then angle B will be equal to 3 times A. So that is 3 over 7. 3 times A is 90, 1020 over 7. Angle C, angle C is 3 over 2. That is 3 over 2 times A, 340 over 7, which is 170, 510 over 7. How about angle D? Angle D is C plus 20. That is 510 over 7 plus 20. Okay. Gabriel, that's it for this week. Okay, thank you very much. Next week, we'll solve question from test. Have a nice weekend. See you next Sunday. Okay. Bye-bye.